A lot of the equilibria we've been looking at in this chapter is all been of the same phase, or a homogeneous equilibria. But now let's look at what happens when we have more than one phase present in a particular equilibrium expression. So because their concentrations do not vary, do not include concentration terms for pure solids and pure liquids in equilibrium expressions. So if we look at a couple examples of this, if we took calcium carbonate, which is a solid, and that's in equilibrium with calcium oxide as a solid, plus CO2 as a gas, we can write a Kc expression for this to be the concentration of products over reactants. But remember, we do not include concentration terms for pure solids. So our Kc is going to be products, which is the concentration of CO2, divided by the reactants. There aren't any that we can include in this expression, so it's just going to be the concentration of CO2 over 1, or the concentration of CO2. If we were going to look at the Kp for this particular expression, it's just going to be the partial pressure of CO2. Remember that the Kp is equal to the Kc times RT to the delta N. Here we're going to have 1 mole of gas as a product, 0 as a reactant, so it's going to be Kc times RT to the first power. If we look at another example where we have 2 H2O as a pure liquid in equilibrium with 2 hydrogen gas plus oxygen gas, our Kc is going to equal the concentrations of the products, which are H2 squared times the concentration of O2, divided by the concentration of H2O, but it's a pure liquid, so it's not going to be involved in this Kc expression. Likewise, the Kp is going to be the partial pressure of the H2, that quantity squared, times the partial pressure of O2. Our Kp is going to equal Kc times RT to the delta N. On the product side, we have 3 moles of gas. On the reactant side, we have 0. So it's just going to be Kc times RT raised to the third power. Next, if we have CuSO4 dot 5H2O, this is a solid in equilibrium with CuSO4 as a solid plus 5 water in the gaseous phase. Our Kc here is going to be equal to the concentration of the water to the 5th power. The other two are solids, so they won't be expressed in this equilibrium constant. The Kp is going to be the partial pressure of H2O to the 5th power, and our Kp is going to equal the Kc times RT to the delta N, which is going to be 5 minus 0, or 5. So here's how you would set up equilibrium constants if you have heterogeneous reactions and those that involve solids and pure liquids.